Click, clack, click, clack.
Want to learn about chemistry?
Ah, Graham, how did we get here?
Whoa, that's insane. What are we learning about today, Ryan?
Solid rocket fuel.
The same solid rocket fuel that was used by the 13th century Chinese to make rocket-propelled arrows? Or the kind that was pioneered by scientist engineer extraordinaire Jack Parsons at Caltech? Which is used today by NASA to get to space, by model rocket enthusiasts to make bigger, better rockets, and is used in other various military applications?
Yes. For our demonstration, we wanted to find out which ratio of potassium nitrate to sucrose was the quickest to burn so we could get a feel for which had the best thrust. We did 6 grams of potassium nitrate to 4 grams of sucrose, 5 grams to 5 grams, and then 4 grams of potassium nitrate to 6 grams of sugar. After massing the mixtures, we slowly cooked them at a mild heat. After a while, they turned into a liquidy brown substance that kind of looked like a caramel. We poured this into an aluminum boat, which we had constructed out of aluminum foil, and let it harden. After that, we took the necessary safety precautions and lit it off. We then timed how long each mixture burned.
Be careful not to get it too hot, or it might blow up in your face. You will know it is done because it will turn into a brown-colored liquid. After you let it cool, it will turn into a very brittle solid. At this point, it is very flammable, so don't burn your eyebrows off.
Potassium nitrate is a common oxidizing agent. It is a major component of many fertilizers and is also a stump remover. The melting point of potassium nitrate is around 334 degrees Celsius.
Sucrose is just the same as common table sugar that you might use to bake a batch of cookies, or to sweeten your coffee. Sucrose will caramelize at a temperature of about 160 degrees Celsius, while it melts at a temperature of 186 degrees Celsius.
When you make the candy, you don't change the potassium nitrate at all. Instead, you get it hot enough to where the sugar melts around the potassium nitrate. This makes the rocket candy, which is the flammable solid substance.
Initially, we thought that the sucrose and the potassium nitrate reacted to make rocket candy, but we later found out that the sugar is just caramelizing around the potassium nitrate, because when cooking rocket candy, you never reach the melting temperature of either substance, but it does reach the decomposition temperature of sugar, which is also the temperature that it caramelizes at.
Demo time!
Wow, Ryan, what a great transition.
Thanks. That's the best way I could think of to transition between our background and our demo.
We started by massing all of our potassium nitrate and then all of the sucrose. We mixed it in the weigh boat to ensure that we had 10 grams of the mixture before cooking, to be certain that all of our samples were the same size. We then prepped our cooking surface first by double checking that the pan wasn't broken, and then checking that the camping stove was on and properly functioning. After that, we would add our pre-mixed rocket candy powder for cooking. You can see us consistently agitating the mixture. This prevents one portion from cooking more than another, a precaution we took to make sure none of the mixture burnt, ignited, or blew up in our faces. After a short while, the sugar would start to caramelize. You can see this in the video by observing the mixture beginning to clump up and become less granular. As this happens more and more, we can see the mixture start to congeal with itself. You can also see how the rocket candy is starting to take on its brown color. Eventually, it takes on its final stage, the viscous brown liquid, thick enough that you can't effectively manipulate it with one utensil. This mixture is ready to be cooled in an aluminum foil boat. I gotta admit, all of that is kinda boring. Let's look at some solid rocket fuel igniting now.
I don't see nothing happening.
One thing we noticed was that the 50-50 mixtures ignited a lot slower than the 60-40 mixtures. While we wait for that to cook, here's the rest of them.
That was the hardest rip.
Now, I'm sure most of you have heard the old adage, modern problems require modern solutions. Well, I think that not being able to light your solid rocket fuel is a pretty modern problem, so I met it with a modern solution.
Thanks for watching our choice project.
If you have any questions, go ahead and ask us.
Either way,